Power transformers remain an essential link in power distribution. Failure of even one transformer causes blackouts and incurs significant expenses to repair or replace the transformer, which may reach into hundreds of thousands or even millions of dollars. That is why long-term reliability of the transformer is so important, regardless of the location, season and weather. Approximately 50% of transformer failures are related to the insulation system, which consists of mineral oil and cellulose-based insulation materials. This percentage is so high because transformer oil and insulation paper are subjected to various physical influences and chemical transformations. Humidification, high temperature, oxidation, etc. These result in aging and degradation of the insulation, which becomes susceptible to electric breakdowns, causing premature transformer failure. Since cellulose is hygroscopic by nature, that is, has a high affinity for water, it is water that becomes the worst enemy of the solid insulation. Entering the transformer from the outside, water and high temperature destroy paper insulation for years. The cellulose molecules break down, the paper becomes brittle and loses its tensile strength. The breakdown of cellulose molecules results in formation of carbon oxide, acids and more water that again reduces the electric strength of the insulation. Graphs show that the higher the temperature and the water content, the shorter the lifespan of solid insulation. Heating of the windings and the insulation in a loaded transformer is not something that can be changed. However, by reducing the water content, the lifespan of the solid insulation and the entire transformer can be increased. Depending on the location, insulation drying may or may not involve extraction of the windings from the transformer tank. GlobeCore has developed technologies and equipment for both cases. Drying the insulation externally can be performed by heating and vacuum in the US vacuum oven. There are several equipment combinations to dry the transformer insulation without extracting the windings. Low-frequency current and a Mojave heat hot air blower, low-frequency current and a CMM-4/7 unit to circulate oil inside the transformer, as well as low-frequency current combined with an INI vacuum cold trap unit. In this video, we present the GlobeCore process to protect the transformer against water accumulation and subsequent damage to paper insulation by continuous drying. The CMM-260C unit is designed for this purpose. The CMM-260C is connected to the bottom and the top of the transformer. A pump transports oil from the bottom of the transformer through 3 zeolite sorbent columns at a low rate. The zeolite absorbs water and captures it reliably in its granules. The dry oil goes back to the top of the transformer. It is possible to use another sorbent in lieu of zeolite in the columns. For example, if the oil requires not only drying, but also acidity reduction, silica gel can be used. The columns can be replaced after complete saturation of the sorbent. The columns are designed for easy replacement, and this operation requires one worker and takes 10 to 15 minutes. The CMM-260C has a strong, durable enclosure to protect against the elements. In this case, the station is called TOR4. If necessary, the unit can be equipped with a diagnostic system, comprised of 2 sensors. The sensors monitor the amount of water at the inlet and the outlet of the system. A user-friendly web interface and oil parameter calculation software are available to the user. A system so equipped is designated TOR5. Let us take a closer look at the drying process. As load and temperature of the transformer fluctuate, water is in constant motion between the solid insulation and the oil. Using the continuous GlobeCore drying, we feed dry oil into the transformer, which takes water from the solid insulation, carries it out, and returns to the transformer dry. The process removes water not only from the oil, but also from the solid insulation. Therefore, this globe core process facilitates keeping the water content in the solid insulation at a safe level, preventing cellulose breakdown. Now, a practical example. One of GlobeCore clients in Latin America used a CMM-260C unit to dry an energized transformer continuously for 8 months. The following results were achieved in that time. Absolute water content reduction from 25 to 14 parts per million. Relative water content in the oil reduction from 16.9% to 9.3%. Solid insulation water content reduction from 1.3 to 0.7%. Looking at the graphs that show influence of temperature and water content on the lifespan of solid insulation, we can see that, for example, reducing solid insulation water content from 1.3 to 0.7% at a temperature of 80 degrees Celsius extends the transformer lifespan by approximately 25 years. In general, using the continuous drying process offered by GlobeCore has a number of advantages. Safe and reliable transformer operation. Increased service intervals. Increased intervals before transformer overhauls. Reduced scope of repairs. Reduced labor and capital costs related to transformer maintenance and servicing. What methods of transformer insulation drying do you use? What is your opinion of the continuous transformer drying technology by GlobeCore? We would like to hear from you in the comments. For more information, please visit www.globecore.com.
www.globecore.com